A few sections ago, when we talked about random variables, we learned how to find the mean and standard deviation for a random variable. So for example, to find the mean of a random variable, we had to do the sum of each x value times each probability. And that wasn't too bad, but the formula for standard deviation took even longer because we first had to find our variance, which was each x minus the mean squared times the probability, and add them all up. And then we would take the square root of that to get our standard deviation. So you can see that using these old formulas took a lot of time. Now the binomial distribution is so common that people went ahead and found shortcut formulas for the mean and standard deviation. So if a random variable x has our binomial distribution with n and p, then the mean and standard deviation of the random variable are going to be, the mean will be equal to n times p. So number of trials times the probability. And the standard deviation will be the square root of n times p times 1 minus p. Again, these come from these basic formulas. It's just we've used some algebra tricks and figured out this will be what it is for every binomial distribution. So for example, in a test for ASP, a subject is shown the back of a card. The card can be a star, circle, wave, or square. The subject is supposed to name the shape on the card. Each subject will look at 20 cards. Now let's assume that each subject is randomly guessing. So first, would this be binomial? Well, we know in advance we're looking at 20 cards. The probability of getting it correct, if you are randomly guessing, would just be 1/4 because there are 4 choices. So probability would be 0.25. If you're randomly guessing, I would think each one should be independent. And you're either correct or incorrect. So 2 choices. So I would say this is binomial. Now with that being said that it's binomial, I already said that n equals 20 because we know they're looking at 20. And the probability of getting one correct is 0.25. Okay, and I don't think I specifically said it, but let's say here that x equals the number correct. So what would be our mean number of correct guesses? Or how many guesses would you expect them to get correct? So our mean, or if you prefer, the expected value of x, it doesn't matter which symbol we use, will be equal to n times p. So in our case, that's going to be 20 times 0.25, which gives me 5. So what does that mean for me? That means if we gave the ESP test to many, many people, on average, each person will guess 5 cards correctly out of the 20. So what's the standard deviation of the number of correct guesses? Okay, for this, all we do is just plug it into our formula of square root n times p times 1 minus p. Square root n times p times 1 minus p. So the square root of 20 times 0.25 times 1 minus 0.25, which gives me 1.9365. This means if we did this experiment many, many times and wrote down each time how many correct guesses people got, we would get a data set such as maybe one person got 3, 2, 4, 5, 3, 4, etc. Okay, so we'd get a really big data set. Let's put a 6 in here. Maybe one person got really lucky and got 8. Okay, we get a really, really long data set. So if we took the standard deviation of this data set, the standard deviation would be close to 1.9365. And now there's a problem for you to try.